Hello class, we're about to start lesson 4.1 from Math 130, and it's titled A Likely Story. We have our learning objectives, which is to understand key terminology in the study of probability, to compute and interpret theoretical empirical probabilities, and number 3, compare theoretical empirical probability. We will get into these topics a little later in the course, but here we're going to start on page 299 in your course pack. So if you don't have your course pack open, please turn to page 299. Now, when you get to page 299, if you notice, it has a lot of things on your course pack that is not shown here. I was not able to put up the full course pack, but you could follow along. The only thing that I have listed here are the problems and the number of the problems, which does not include the directions. So I will be reading the directions from the course pack. All right, so it says here, in this lesson, we'll examine the basic concepts involved in studying probability. In short, the probability of something occurring is a number that represents how likely it is to occur. You can think of it as the percent chance of something happening. The major difference between percent chance and probability is that we write probability as a number between 0 and 1. So that is a very key feature. It's a number between 0 and 1, which means that it cannot go below 0, which means it cannot be negative, and it cannot go above 1. 1 is the highest number that a probability could be, and 0 is the lowest number that a probability could be. Okay, so in that regard, it's like percent chance with the percentage written in decimal or fractional form. So we come here to problem number 1. It says, a forecaster says that there is a 70% chance of rain today. What is the probability of rain? Now, as you all know from previous chapters, when we covered percents, we know percent means out of 100. So we know 70% actually means 70 over 100. And when it's simplified, that means that it's 7 out of 10, because we can divide the numerator and denominator by 10. So the probability is 7 over 10, or you can write it as a decimal as 0.7. So either one of these will be listed as a probability depending on the situation. Now we come here to problem number 2. Now remember, problem number 2 in your course pack starts on page 300. Now before we get to problem number 2, there's a tan box that's at the top, and it says sample spaces. Processes such as flipping a coin, rolling a die, or drawing a card from a deck are called probability experiments. A probability experiment is a process that leads to well-defined results called outcomes. An outcome is the result of a single trial of a probability experiment. So we get to number 2. It says some examples of a trial are flipping a coin once, rolling a single die, and drawing one card from a deck. So number 2, when a coin is tossed, there are blank possible outcomes. List them. Now, when a coin is tossed, there are only 2 possible outcomes. Now, the 2 possible outcomes on a typical coin, and we're talking about U.S. money, would be a heads or tails. Those are the 2 possible outcomes. So now we come here to number 3. It says when rolling a single die, there are blank possible outcomes. Now, we're talking about a regular die, a regular 6-sided die, which would be 6 possible outcomes. Now, those outcomes are 1, 2, 3, 4, 5, and 6. Okay, now, we go here to number 4. Now, number 4 has directions, and what you can do, well, I'll read through them. It says, in a probability experiment, we can predict what outcomes are possible, but we can't predict with certainty which one will occur. We say that the outcomes occur at random. In any experiment, the set of all possible outcomes is called the sample space. What you did in question 2 and 3 was find the sample space for 2 different probability experiments. For each experiment described below, write the sample space. Well, for each experiment described below, write the sample space. The first is filled in for you as a reminder that a sample space is a set. And we will write sets inside braces with commas separating the elements. Now, if you look here, if you look closely in your course pack and also on this video, if you notice, we do have a sample space here, and they use braces to let us know that this is a set. And we talked about the flipping of the coin. You had heads and tails. We have here. Now for the die, we would do a brace. And it's a little hard doing it with this tablet, so I'm going to try my best to make it look as good as possible. So we have 1, 2, 3, 4, 5, 6. These are all the possible outcomes on a die. Now it says answer a true-false question. So when you answer a true-false question, you can only answer it true or false. So that is the set. And then flip 2 coins. Now, this is a little different when we're flipping 2 coins. So we're going to list the possible outcomes for flipping 2 coins. You could get heads twice. You could get a head first and a tail second. Or you could get a tail first and a head second. And last but not least, you could get 2 tails. These are all the possible outcomes when you flip 2 coins. Okay, now we move on to problem number 5. It says here, in finding probabilities, it is sometimes necessary to consider several outcomes of a probability experiment. For example, when a die is rolled, we may want to consider obtaining an odd number. There are blank outcomes that satisfy this criterion. List them. Now remember, if we go back to where we had in the on the previous slide here, where we looked at the die, they said in this next problem that they're talking about the odd numbers. The odd numbers here on this die are 1, 3, and 5. So if we go back to problem number 4, well, I'm sorry, slide 4, problem number 5, we notice that there are 3 outcomes that satisfy this criteria of rolling an odd number on a die. And those 3 numbers are 1, 3, and 5. Now, at the bottom of page 300, it says an event is any subset of the sample space for a probability experiment. This means that an event can be a single outcome or a set of several outcomes. Now we come here to number 6. It says you already listed out the sample space for flipping 2 coins. Look back at the table on the previous page and make sure that you have 4 outcomes in your sample space, which we do. We could take a quick look back. We have our four answers here in our sample space. So we go back here, and it says how many results match getting heads on the first flip and tails on the second flip. And it's only 1. And if you look back here, we head on the first flip, tails on the second flip, and none of the others are the same. So it's only 1. Now it says here, number 7. It says how many results match getting 1 head and 1 tail. Now we go back here. We have 1 head, 1 tail, 1 tail, 1 head. So it's only 2. So our answer here would be 2. Now we move on to the next slide. It says identify each scenario in questions 8 through 10 as an event, an outcome, or both. Now this takes a little reading and a little understanding. It says when rolling 2 dice, getting 3 on the first die and 5 on the second. This is an outcome. and it's also an event. Now, what you could do is you could go back to the previous pages and read the definitions of an outcome and event, and you will see that it ties directly to problem number 8. Now, number 9, when rolling 2 dice, getting a total of 10. Now, this is an event. And then finally, number 10, when flipping a coin 10 times consecutively, getting tails 8 times. Okay, now, this is an event. Okay, now, again, you can look back at the definitions. If you don't understand it, when you come to class, we could discuss how these are outcomes and how these are events. All right, now, we'll go here to problem number 11. Now, problem number 11 is actually on page 302. And this is dealing with theoretical probability. Now it says, now we're ready to specifically define what is meant by probability. The first type we'll study is called theoretical probability. The goal is to determine all of the possible outcomes in a sample space and determine the probability or likelihood of an event occurring without actually performing experiments. There is one key assumption we make in theoretical probability, that every outcome in a sample space is equally likely. For example, when a single die is rolled, we assume that each number is equally likely to come up. When a card is chosen from a deck of 52 cards, we assume that each card has the same probability of being drawn. Okay, so now, we always have to take into account that each outcome is equally likely. So we look here at number 11. It says you have to be awfully bored to flip a coin 100 times. But if you did, about how many times do you think it would land tails up? And if each outcome is equally likely to happen, since there's only 2 outcomes, it should be half the time. Which is 50, which is 50. So we could put with confidence about 50. Now it says number 12, what percentage of the time would you expect the coin to land tails up? So if it's about 50 out of 100, it's 50%. Now it says write a fraction with the number of flips in the denominator and the number of times you're expecting it to land tails up in the numerator. What does this have to do with your answer to question 12? So this will give us 50 out of 100, because 100 is how many times we actually flipped it, and then 50 is how many times we expect tails to come up. Now, and we know that equals 50%. Now, we get this from question 12. All right, now we're done with this set. Now we will move on to slide 7, which starts with problem 14. But before we do 14, you notice on page 302 at the bottom in that tan box, we have a formula here for calculating a theoretical probability. It says the probability of an event E in a sample space S occurring is given by the probability of the event is equal to the number of outcomes in E divided by the number of outcomes in S. And then we have N of E and N of S. Now it says for questions 14 through 16, a single six-sided die is rolled. Find the probability of each event. If you need to, look back at your sample space on page 300 for reference. Okay. What this is saying is, what is the probability of you rolling the 2? Remember, you have 6 chances of getting a 2. Well, I'm actually saying it's 6